we are going to be talking about exponential equations. So last unit we had linear equations and we used y equals mx plus b, right? But now we have exponential equations. And the exponential equation, make sure you write this down in your notes because this is something you're going to be using throughout this unit, is y equals ab to the power of x. And we remember for linear, we were adding or subtracting. So we used y equals mx plus b. Okay, so that was linear. Exponential is whenever we see multiplication or division. Okay, so make sure you write that part down as well. Okay, so y equals abx. Obviously, nothing's going to go in for y and nothing's going to go in for x. Just like our linear equation, we always left y and x alone. A is the starting value. Okay, so let's say we start with 10 minutes of study time, okay, or we start with 5 rabbits. Okay, so A is the starting value, and B is the growth or the decay factor. So what we're multiplying or dividing by. And some people like to think of A being like the y-intercept in a way, okay, because technically that would be like our starting value. Okay, but I'll be going through some examples where that might not necessarily be our starting value. So pause the video and take down these notes if you haven't already. We are going to be going through about 9 or 10 examples. I recommend that you pause the video in between each example so that you can write down the table. There's going to be multiple tables as well. Each table is a little bit different. Some of them you'll notice will be kind of similar. Now, if we're looking over here on our y's, we notice that we add 2, add 4, add 8, add 16. So this can't be linear. Okay, so then I move on to my exponential. Going from 2 to 4, I'm multiplying by 2. 4 to 8, I'm also multiplying by 2. 8 to 16, that's multiplying by 2. And 16 to 32, that's also multiplying by 2. So since we are multiplying by the exact same number all the way down, we can say that this is an exponential. So I'm going to be using y equals ab to the power of x. Remember, a is our starting value. Okay, so right here, 2 is our starting value, so I'm going to write y equals 2. Next, b is our growth factor or our decay factor, and that's what we're multiplying by. Okay, notice we are multiplying by 2. Okay, so this is technically multiplication in between a and b, so to separate that out, I'm going to use parentheses. And then we have it to the power of x. So this would be the equation for this table. Example number 2. Again, pause the video, write down the table quickly. Notice I'm going from 1 to 3, then 3 to 9, 9 to 27, and 27 to 81. I'm not adding by the same number, I'm not subtracting by the same number, so this has to be exponential, hopefully. So 1 to 3, that would be multiplying by 3. 3 to 9, also multiplying by 3. And it looks like it works for the rest of the table. Okay, you may need your calculator to make sure that it's the same all the way down. So I know I'm going to be using my y equals ab to the power of x. First, my starting value is 1 this time. So I have y equals 1. Then my b is my growth factor. Since we're increasing 3, I put parentheses around it to the power of x. I'm not putting like the dot in between or the multiplication sign in between, because the dot can look like a decimal point and the x or the multiplication sign can look like an x. That's why I chose to use parentheses to represent multiplication between the 1 and the 3. Example 3. Again, very similar to the last two, but I just want to make sure that we're all on the same page. So if you feel like you understood the first two, pause the video, try and write the equation yourself, and then check it with mine. First thing, I notice I'm multiplying by 4 all the way down. So I'm going to know it's going to be exponential. My starting value in this case is 1. So I have y equals 1. My growth factor is 4, because that's what I'm multiplying by, and then to the power of x. Okay, so check yours, that yours looks like this. Now, example 4 is different than the last 3. Okay, so if we were to go back and look at examples 1, 2, and 3, you'll notice that we don't have a 0 value here. And all of the other ones, we had 0 as our starting point. So if you look back at your notes, okay, or if we go back, so look at example 1, we had a 0 we started with. Okay, again, with example 2 here, we have a 0. And example 3. Notice example 4, there's a 1. Now, we're still going to do everything the exact same. There's just going to be one difference. So notice here, we are multiplying by 3 all the way down. I checked in my calculator. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I know that this is going to be exponential because we're multiplying. So I have my starting value is still 3. So y equals 3. My growth factor is also 3 because we're multiplying by 3. Now, the exponent is the only thing that changes here when we don't have a 0 here. Notice we have a 1. So instead of just putting x, I'm going to put x minus 1 to represent that we didn't start at 0. Right? Technically, in our original equation, that meant minus 0, but I think most of you know that to subtract 0, we don't need to write that. Okay? If we were to start at 2, like let's pretend this wasn't here, we would then have x minus 2 here. Okay, so it all depends on what that x value is. Okay, so we're going to pay extra close attention to that in the next few. Next example, okay, I'm going to check to see what's going on. Okay, again, pause the video to take notes and sketch the table. I'm multiplying by 2. It looks like all the way down the table. Okay, so I'm going to use y equals ab to the power of x. My a, or my starting value, is 5. My b, my growth factor, is 2. Now, my exponent. Since I have a 1 here, I have to put x minus 1, since I didn't have a 0 to start. Again, pause the video take down the notes. This one is different than the others. Hopefully, you notice that, oh, we aren't multiplying. We're actually dividing by 2 every time. Now, when we put our decay factor in, we don't put dividing by 2 into our b. We have to think about what we are multiplying by. So what's the same thing as dividing by 2? Would be multiplying by what? If you're not sure, right, dividing by 2 is the same thing as multiplying by 1/2. If you're still unsure on how I got to 1/2, you can always take your second number, 50, divide it by the first number, and that will give you your decay factor, what you're multiplying by. Okay, we'll do that a couple times in the next few examples. Okay, but first, let's look at what the equation would look like. A doesn't change. A is always, always, always our starting value, which is a 100 in this case. B is always what we're multiplying by. Okay, so I'm not going to put 2 in there or dividing by 2. I'm going to put 1/2 because I'm multiplying technically by 1/2. That's the same thing as dividing by 2. Just like the previous examples, okay, we want to look at our first x term. Since we started at 1, remember we want to put x minus 1 in that spot. I know that's a lot to take in. Okay, pause the video. Okay, maybe rewind if something didn't make sense, but we're going to go through a couple more examples. All right, example number 7. Again, I notice this isn't linear, okay, and I'm not sure what we're multiplying by. I know that we are dividing by 3, but if you're not sure on what that decay factor is, take that second number, 81, and divide it by your first number. When you look at that in your calculator, it should give you 0.333 repeating, which means 1/3. So technically, we are multiplying by 1/3 all the way down. Right, that will give us a decreasing. So I know since we're multiplying, we're going to have an exponential function. A is always the starting value, 243. B is what we're multiplying by. In this case, it's a decay factor since we're decreasing, so 1/3. And then our x, notice we're starting back at 0, so I can just put x. Example 8. Example 8 here, notice I can't really tell what we are multiplying by or what we are dividing by, so I'm going to get my calculator out. And let's go back to the right slide. This one. And remember how I said you can take that second number, 180, and divide it by the first number. And that will give us what we are multiplying by. So even if we're increasing or decreasing, you can always find that multiplying factor. Then you can double check that 1.8 is actually correct. Right, by typing in 100 times 1.8, 180 times 1.8, and so on and so forth. Okay, so we are multiplying by 1.8 here. all the way down because I double checked. You should always double check. So we have exponential. 100 is my starting value. 1.8 is my growth factor since we're increasing as we're going. And my exponent is just x since we started at 0. Last but not least, here I notice that we're going from 100 to 25 to 6.25. So again, get your calculator out, take 25 divided by 100. You should get 0.25, or that's the same thing as 1/4. So we are multiplying by 1/4. So A is my starting value. I started with 100. I'm multiplying by 1/4 all the way down. And I have 1 here. So I have x minus 1. I understand that exponential is a little more complicated than linear. So if you need to, go back through the video, ask your teacher questions if something didn't quite make sense. Right? Go through the practice problems, make sure that you understand.